Standing waves. So these were what we were studying in the investigation in class. So at the fixed end, an incident crest becomes a reflected trough, as we learned in the previous video lecture. And so if that process is repeated periodically, and the timing is just perfect, you will actually get, a larger standing wave. So you see here, the wave that is blue moving to the right is interacting with the wave that is green moving to the left, and you get interference, which is causing that standing wave, the black one. Let's review nodes and antinodes. So the places that do not move are called nodes. The places that move the most are antinodes. All right, and so here's a picture of what those would look like in a standing wave. Notice here both ends are fixed. So there's another word we use in physics, and that's harmonics, and we talk about this in order to have some vocabulary to talk about those different standing waves you can get. So the first harmonic, is like just a plucked guitar string or violin string. The two ends are fixed and the middle is free to move the most. I know if you play an instrument, this is confusing. It's what you would call the fundamental, and we also use that term here. Your second and third harmonics, your second harmonic, the two ends are fixed, and you have two half wavelengths, So you have one full wavelength in your standing wave. Your third harmonic has three half wavelengths, or 1.5 wavelengths, in your standing wave. So again, if you play music, the second harmonic is the first overtone, the third harmonic is the second overtone, etc. So in summary, the relationship between harmonics and wavelength looks like this. So one complete wave has two loops, if you have one wavelength in your standing wave. And each of those loops is a half wavelength, and I'll let that play through a couple of times. And so that's hopefully what you developed in class. The nth harmonic, if L is the length of the string and lambda is your wavelength, your number of half wavelengths divided by 2, equals the length of the string. Okay, here, your fixed variable would be the length, and you're varying your wave length by varying the frequency in order to get the nth harmonic.